चौथी क्लास में हमने पीवी सोलर पीवी सिस्टम के बारे में डिस्कस किया था. In that we have discussed the major parts of the solar PV system like solar panel, battery and inverter. आप स्क्रीन में देख सकते हैं. You can see a lot of other components are also involved in the solar PV system. So this is a picture of a standalone PV system. You can see the solar panel, battery and inverter. But as a system, we have a lot of other components like DC disconnect, charge controller. All together we are calling it as a solar PV system. So many items, components, parts are there in the system. Right from the sunlight is converted into electrical energy, and we are getting the electrical energy into the load. So you can see so many components. And today class will discuss about the various small components involved in the system, and we call it as solar PV balance of system. हम ये पूरा बैटरी, इन्वर्टर और सोलर पैनल छोड़ के बाकी को हम बोलते हैं, सब मिलके बोलता है सोलर पीवी बैलेंस ऑफ सिस्टम, मीन्स अदर पार्ट्स. So today's class we'll see, we'll list out what are the components in the solar PV system, what are the systems components involved, and all those components will not be able to explain today within one hour. So this is a part 1. So we'll explain today what is a charge controller, what is the significance of charge controller, how it works, and AC DC distribution boxes. There are so many DC and AC distribution boxes are there, and then we'll see various types of cabling and their connectors. These three things will be explained. So first let us see what are the components. क्या components होती है. There is an inter-array DC cabling. Array we have already discussed. That is the group of solar modules connected. So modules should be connected together. That is called array. And under array DC cabling and cabling to junction box. Then array junction box, combiner box. Otherwise it is called as combiner box. A DC distribution box is called combiner box also, or array junction box, and AC distribution box also. Then we can see the protection, various protections are required, various disconnect switches are required. Disconnect is also a name normally we are using in the solar PV system. हम for solar PV system में जो like MCB वगैरह है, तो connect and disconnect, उसको हम solar PV system में disconnect बोलता है. Okay, then lightning protection, this is very dangerous. Lightning, we have to protect our solar PV system from the lightning. बिजली से protect करना है. So with various methods are used. Then isolators, DC isolators are there. Then AC isolators are there. Isolate का मतलब क्या है? अलग करना है. तो कैसे अलग करना है? किसे अलग करना है? कुछ आपको maintenance करना है. We have to do some maintenance, or some fault is there. That time we have to separate the system. So for that we are using the isolator like normal electrical system. Then like DC cabling, AC cablings are there. From inverter onwards it is AC supply. So AC loads के लिए जो वायर जाता है, केबल जाता है, that is called AC cabling. And metering, how much energy we are able to harvest, कितना हमको एनर्जी मिलता है, कितना कंज्यूम होती है, ये इसका मीटर्स होता है. And nowadays system monitoring is there. All the parameters will be displayed by various methods, and we can interface with the computer. We'll get the website display also. So these are all coming under the balance of system. So some of the items we will be discussing today. Some rest of things we will be discussing later. So first of all, we will see battery charge control. This is after inverter and battery. This is another important part in a solar PV system. This is called battery charge controller. So as the name implies, it controls the battery charging. Not only battery charging control, it is protection. It is giving protection to the battery, and it is preventing the overcharging and over discharging. last class we have discussed about battery, solar battery. So the ill effect, the problem if you are charging, overcharging or over discharging, हमने देखा था, there will be so many problems with the battery. So it should be charged up to the permissible level. जितना permissible है उतना level पे हमको charge करना है. उससे ज्यादा चार्ज करेगा तो बैटरी के लिए प्रॉब्लम है, बैटरी प्लेट बेंट हो जाएगा, there will be a sort of problem. Same way, discharging. We are discharging to the load. When the discharging is going DOD, beyond DOD we have discussed last class, the maximum depth of charge we can go, that is DOD. So we go beyond that, if you go, it will be causing sulfation-like problem. You cannot, the life of the battery will be ended. So battery protection is required. So your charge controller, it is protecting your battery from overcharging and over discharging. Okay, our problem with the solar system, आपको पता है, our solar output is continuously varying. It is not a constant supply. Depends upon the time, depends upon the weather, depends upon the position of sun with respect to your solar system. So इसका अनुसार आपका जो radiation मिलता है, उसको change होता रहता है. So output also it is varying. And same way, the load is also varying. Sometimes we will switch on all the load, sometimes some part of the load आप on करेंगे. So load condition and input conditions are varying. But the battery should get a constant charge. So battery, irrespective of the supply, solar from the solar module, battery should be tuned, refined, and should be connected to the load or the inverter. Sorry. So all these functions are being done by charge control. So it is not required for all the design. Wherever we are using battery like standalone power system and like what you say hybrid power system, you can use the charge. You can see the charge controller. Okay, so function together I will tell you. Excessive battery charging, it is preventing excessive battery charging, battery ka overcharging, then battery ka over discharging, and it is a load control. It is a load control function. I said it can control the as per the load, whether supply should go from battery, whether the supply should go directly from the solar module. That all will be controlled by the charge controller. And it gives the status information. So many indications will be given. So in the indication, battery is connected or not, battery is getting charged or not, battery is over discharged or not, whether the module is working or not, all the functions, all the display आपको मिल जाएगा. And it interface the control backup energy source. And control, that is sometimes backup energy, other source also if you are using, like another alternator or diesel generator, something. So that also will be connected. When to be connected? When, so for example, solar module is not giving the supply, night time. So battery should be charged. That time it will automatically change over the source of supply from solar module to another our standby supply source. So like these functions, the charge controller is doing. It is diverting PV energy to an auxiliary load. The same time, while your battery is getting charged, आपका other loads के भी load में भी solar module से supply दे सकता है. If battery doesn't require that much power, the excess power can be diverted to the load. So battery charging and the load, for example DC load, can be energized together simultaneously. And it works as a wiring center. You can see all the wires coming from the combiner box, DC solar module. And from there it is going to the inverter. So in between your solar charge controller is battery charge controller is working. Okay. So now we'll discuss about the solar set point. You can see a figure. There are two sections: charging and discharging. Your main function of the charge controller is charging the battery or making the battery to discharge to the load through the charge controller. So how much it can allow charging? So when the solar module is connected to the battery through the charge controller, your battery is getting charged. Okay, fine. आपका बैटरी चार्ज हो रहा है. कब तक चार्ज होगा? So there is a limit, as I said. So आपका charge का certain voltage होती है. For example, 12-volt battery system, up to 13 volt your charge controller. This is only an example. 13 up to 13 volt your battery will be getting charged. So beyond that your battery should not be charged. Charge नहीं होना चाहिए. So that is a cutoff point where your charge controller will switch off the charging process to the battery. So this top maximum voltage is called regulation voltage, VR. That is a maximum voltage the controller allows the battery to reach before the array is disconnected. So 13 volt से ऊपर नहीं होना चाहिए, that is preset. तो 13 volt attain करेगा, आपका बैटरी fully charge हो गया, आपका बैटरी चार्ज सेंस करेगा, बैटरी चार्ज will stop charge. Now your battery is getting discharged. Simultaneously your battery getting discharged also to the load. So what happens? The battery voltage will be getting reduced. Okay. Now so up to certain voltage dropping, your battery charger will wait. When it is reaching to a particular voltage, see this point. Again your battery charger will charge the battery. Allow the solar motor supply to charge battery. So this point is called array reconnect voltage, ARV. Voltage at which the array is reconnected. 13 वोल्ट में हो गया था, उस समय बैटरी कट ऑफ हो गया था चार्जिंग, लेकिन उसके बाद बैटरी डिस्चार्ज हो रहा है, मान लीजिए अराउंड 12 वोल्ट हो गया, 12 वोल्ट में फिर उसको चार्ज करना है. So this 12 volt supply volt point is called ARV. So this voltage swinging, the voltage span between the PR and ARV is called voltage regulation hysteresis, VRH. This is the period where the pulse modulation is happening. Okay, so this is the function happening during charging the battery. Okay, and come to the discharging point, you can see same way, battery will be getting discharged through the load. So how much you can discharge? So that is also there's a setup point. तो मान लीजिए आपका बैटरी डिस्चार्ज होके 10.8 वोल्ट हो गया, तो 10.8 वोल्ट इज द DOD max depth of discharge, that is the permissible voltage you can go down. So after that your battery should not be discharged to the load, there will be a problem for the battery. तो क्या करेंगे, your battery charger will disconnect your battery from the load. So the voltage at which the load is disconnected, आपका लोड डिस्कनेक्ट कर दिया, that voltage is called a low voltage load disconnect, LVD, low voltage disconnect, LVD. यहाँ पे आपका लोड डिस्कनेक्ट हो गया. ये सब सारे काम आपका बैटरी चार्ज कंट्रोलर कर रहा है. ओके, नाउ अगेन बैटरी शुड बी चार्ज, बैटरी विल बी चार्ज अगेन, विच विल बी कनेक्टेड. सो but immediately your load will not be connected again. आपका load immediately connect नहीं होगा. When it is getting certain voltage, मान लीजिए 11 volt या 12 volt, 12 volt में आपका बैटरी फिर लोड में कनेक्ट होगा. So this voltage is called load reconnect voltage. Load reconnect voltage, LRV. So here this is the point up to which a battery is charge controller is allowing to charge. VR. ARV is the point again after when the voltage is coming down, after the load is connected, then there's a point battery is coming down. From there again it is going to be connected. That point is called array reconnect voltage. The voltage at which the load is disconnected is called LVD, and the voltage at which the load is reconnected is called LRV. And this voltage span is called low voltage disconnect hysteresis. I hope you understood. Just you can compare with the automatic water filling system. आपका वाटर टैंक में क्या होता है, ऑटोमेटिक वाटर फिलिंग सिस्टम अगर होगा, when the water level is gone up to maximum पहुंच जाएगा, आपका पंप will be switched off, पंप ऑफ करेगा. लेकिन आपका वाटर टैंक से पानी आप यूज कर रहा है, अगर आधा लीटर यूज कर दिया, तुरंत पंप ऑन होना चाहिए, लेकिन ऑन नहीं होती है. So the pump is waiting through your intelligent system. Your pump is waiting to come down to the water level down up to certain limit. आपका वाटर टैंक 1000 लीटर है, 900 लीटर पहुंचने तक वो वेट करेगा, 900 लीटर में फिर स्टार्ट करेगा पंप। तो दिस इज व्हाट इज हैपनिंग हियर, चार्जिंग साइकिल। सेम वे आपका कितना आप पानी निकाल सकता है, फुल वाटर विल नॉट बी एम्प्टीड, आपका पूरा पानी निकालता नहीं, तो नीचे कुछ होती है, सेडिमेंट्स होती है, तो कुछ 100 लीटर होना चाहिए, 100 लीटर में पहुंच जाएगा, आपका वाटर सप्लाई आउट करेगा। लेकिन फिर वाटर पंप ऑन करेगा, मान लीजिए 500 लीटर पहुंच गया, फिर आपको पानी, यू कैन टेक द वाटर। So this is the resembling to the discharge. So this is what is happening in the battery charging discharging. So now let us see various types. There are two types, mainly two types of charge controller. The first one is called pulse width modulation type, PWM, pulse width modulation. So this is a figure of a PWM type voltage charge controller. Second one is the maximum power point tracker. You will be familiar with this point, MPPT. Already we have discussed. So the charge controller works on the principle of MPPT. It's called MPPT type charge controller. These are the two figures you can see. So let us discuss first the pulse width modulation type battery charge controller. So here there is a symbol diagram given. This is a PV panel, battery and load. So there are two switches are there. Actually speaking, PWM is just like a switch. It is just like a switch. Your solar PV is directly connected. Supply of PV module is directly connected to the battery and the load through the switch of a PWM charge controller. When the PV panel is giving supply, positive supply will be going through here, and whenever the voltage is, battery voltage is low, less than the preset value, this switch will be on. Okay, so this switches will be on and your panel is charging the battery like this. The circuit is completed through the now closed contact. Your battery is getting charged. Okay, so when the battery is getting fully charged, this switch will be open. Yes, आपका circuit बंद कर देगा. So there is no supply going to the battery. Now the load is getting supply from the battery. So when in some system both switches will be on, simultaneously battery will be getting charged and your auxiliary load also will be getting supplied. One is like this. The supply to the load is going like this through the switch to the module. When the battery is fully charged, this switch will be open. No more battery charging will be there. Now your load will be getting supply from this battery and to the load through the switch is going like that. So this is what is happening in the pulse width mode charge controller. Now whatever the voltage is set, for example 13.5 volt आपने set किया, so it will be accepting only 13.5 volt and the corresponding current only. Whether solar module is generating more voltage and current, irrespective of that, this is fixed. So this is just like a switch. Okay, so the PWM controller is a switch only. It is connecting the solar panel to the battery. Okay, so I just explained with the IV characteristics curve. So this is the IV curve of a solar module. This one we have already explained earlier. This blue line is the IV curve of at standard test condition, for example 25 degrees Celsius. Okay, so this red line is called the power graph. This is showing the power. So this is the maximum power the solar module is giving. The voltage corresponding to this point is maximum power point is this one. For example, we can say this is 20 volt, and the current is this is the current point, 6 ampere. Okay, but your battery PWM charge controller, the voltage is set, charging voltage is set. Okay, now for example, I'll tell you 13 volt and 0.5 volt for the load. We have set your PWM charge controller has set a charging voltage of 13.5 volt. So 13.5 volt is somewhere here. Okay, so 30.5 volt here, this is not the maximum power point. So you will get a maximum power like this only. The corresponding voltage for this 13.5 current for the 13.5, for example 6, we can say 13.5 into 6 ampere. We are utilizing only 81 watt, whereas the solar panel maximum power is 400 watt, for example. So out of 100 watt, we are getting only 81 watt. Why? क्यों ऐसे क्यों होती है? Maximum power point ट्रैक नहीं किया है. So this is the blue color. The voltage is set. आप 13.5 वोल्ट यहाँ पर है. 13.5 वोल्ट का corresponding करंट होती है 6 एम्पियर. तो अगर आप 13.5 वोल्ट एक्सेप्ट कर रहा है, 6 एम्पियर करंट आप ले सकते हैं. Okay, so 13.5 into 6, 81 watt. Okay, so you are getting only 81 watt power. Your battery charging is comparatively less than the MPPT type charge component. Okay, so now let us see what is happening in the MPPT type. Okay, so MPPT type, see, this is the simple circuit for this one. Additional one DC to DC converter switch is there. That means your solar panel is not directly connected to the battery or the load. It is connected through, MPPT is there, then it is connected through a DC to DC converter, just like a transformer. We can say this just like a transformer. What is the purpose of DC to DC converter? You will get a preset value of output voltage without compromising with the power. So transformer, you all know, when it is transferred from primary to secondary, voltage can be changed. It can be stepped up or stepped down. So current also will be changed accordingly. आपका current accordingly change होगा, क्योंकि आपका power same रहेगा. Okay. So here DC to DC converter purpose is your output voltage is pre-decided, but you will get the maximum power whatever you are producing from here. So let us see how the circuit is working. When solar power supply is connected to the battery and load through the DC-DC converter, it consists of DC-DC converter circuit and switch also. When the switch is closed, supply will be going through this, battery is getting charged. And through this switch, your auxiliary load is getting the supply. The output of the DC-DC converter is only given to the battery and the load. So, iska output fixed hai, voltage fixed hai. Okay. Now, whenever this is open, it stops the battery charging, and there is no supply from solar panel to load also. Your battery, if it is fully charged, your battery will giving you supply to the load. Okay, this is what is, so this is indirect connection. We can say the solar panel is not directly connected, it is indirectly connected to the battery and load. Okay, so let us see the what is happening here. Already explained. This is the maximum power point. This is the voltage corresponding to maximum power point VM, and this is the current 7 ampere. So 7 into 18, it is a 100. You can say 18 volt into 5.56. This is the curve. This is the 18 volt. This is the 5.56 around here, 5.56. So 18 volt into 5.56 is the 100 watt. Okay. So this is the voltage VM and current IM, maximum voltage and IM, which we can take when the module is producing 100 watt supply power. Okay. But our battery voltage we have to control. Our battery voltage we can set to 13 volt. Okay. Now we'll be giving same 100 watt power to the 100 watt power corresponding voltage, we can say 18 volt. So 18 volt supply 5.56 ampere current, together we can say 100 watt. It is applied to the input of the DC to DC converter. आपका DC to DC converter का input कितना होता है? 100 watt पूरा होता है. But your DC to DC converter क्या करता है? इसका output voltage 18 से 13 कर देगा. 13, yeah, 13.5. So after voltage is reduced from 18 volt to 13 volt, what will happen to the current? We all know 100 watt power divided by voltage, you will get the current. So it is 7.7 ampere current. Okay, so your DC to DC converter giving you 13 volt only, like earlier PWM system, but your current is increased from 5.56 to 7.7 ampere. So your battery is getting more charge. So whenever the module is producing more power, that will be tracked by MPPT, and your maximum, it will be operating at the maximum power. That means the IM, VM will be the corresponding to the maximum power. That power, full power we are utilizing to charge the battery by fixing the voltage 13, of course, but increasing the current correspondingly to 7.7. So this is both, we can say 100 watt only. So maximum power point 18 into 5.6 is also 100 watt, but your battery charging, battery voltage and battery current, EBAT and IBAT, that is 13 into 7.5. So 18 को आपने 13 कर दिया, so 5.6 बढ़ गया, 7.7 हो गया. Whereas आपका PWM method में there is a waste. You are getting, your battery is getting only 81 watt power. So this is what is the difference between what you say PWM and the MPPT charge controller. Okay, we can just have a close comparison. By cost wise, PWM is very less cost compared to MPPT because of some electronic circuits are the MPPT convert the DC to DC converter, or we can call it as DC transformer. ये सब होती है. So cost PWM का कम होता है, लेकिन it is more expensive in the MPPT. And its lifespan is more because it's complicated circuit नहीं है PWM में. So life durable. This is durable, we can say. Whereas because owing to the so many electronics components extra, your MPPT is having less life. And this is a smaller size again. Components are less PWM, and it is a bigger size. Okay, so it cannot be used with the 60 cell bigger solar power system. PWM method is the base. It cannot be used, whereas this is very suitable for the MPPT. MPPT is suitable for the system, higher system, bigger system. Okay, so sizing. What is the meaning of sizing? Sizing means designing. So if you want to install a plant, you have to decide what type of inverter you require, what type of batteries required, how much is the capacity required. So that process is called sizing. In the solar PV system, we are using the word sizing. Okay, so during sizing, this is we have to do very carefully because PWM method, there is a wastage. Battery should get proper voltage power, but your panel should have more power capacity than the requirement. Then only you will get the correct power to the battery. So we have to be very careful by selecting number of PV modules and size of it. Okay, so this is the comparison. Which charge controller has higher efficiency? कौन सा charge controller आपका ज़्यादा efficiency देगा? Maximum power आपको देगा? या PWM type है या MPPT type है? ये आपको answer देना है. So next we will see array junction box, AJB, or the combiner box. This is a photo of a combiner box. This is a junction box, distribution box also we can call. So this is a DC junction box. So as you all know, the solar PV system comprises of two type of system supply, AC and DC. From solar panel to up to the input of the inverter, it is DC. From output of the inverter up to the load, it is AC. So in between, we are using the junction box. So this is called a DC junction box, or you can call it as a combiner box, or you can call it as an array junction box, AJB. So this is bringing the output of all the solar panels together to this one. You can see here, inputs are there, outputs are there. So many protective systems are there. Sometimes in some combiner box, monitoring system is also there. So overcurrent protection, overvoltage protection, anti-surge protection, this all we all discussed this one later. Okay. So this is called array junction box. Monitoring device, metering device also will be there. It improves the safety of the solar panel. It will connect and disconnect. Combiner box should reside in this. Normally here this is between the solar module and the inverter. So it should be as close as to the solar module to reduce the length of DC wires. So DC wire is normally low voltage side, considered as low voltage side, and AC is higher voltage side. So low voltage means your for a given power, your current will be more. So current will be more means IR drop will be more loss, I squared R loss also will be more. So it is always better to reduce the DC line. So you connect the AJB as close as to the solar module. Okay, so that will decide how much optimally we can use the solar power. So here in the figure you can see the various parts of solar AJB. So these are the input. You can say MC4 PV input. So from the solar module, solar string supply, DC supplies are coming. So different strings already we have discussed about the string and all. अब हम लोग string क्या है, module क्या देखा हुआ. तो हर string से supply आती है, positive and negative. So this is the DC output. MC for PV input. Though this is the PV input fuse protection. Fuse or circuit breaker will be used through this is a DC protection. Whenever over current is there, it will be getting fused. It will disconnect solar module to various other components. Okay. So from this one, it is going through the diode protection, protected like blocking diode. In case it prevents the reverse flow of current from the load, from the charge controller to the module. Module में reverse current नहीं जाना चाहिए, तो हर point में seriously एक blocking diode दिया हुआ है. So here you can see link, and again it is together given to DC output. This is the sixth one is the DC output, and this is the lightning protection. Here all the DC inputs are joined together. One positive and negative are coming from here. This is the negative. Blue lines are called negative. It is coming here, and the all individual positives are joined together. One single output is coming. This is the positive and negative are going to the lightning protection. From lightning protection, it is again going to negative. Again, it is connected to a output output circuit breaker. See, you can see number 5, 125 ampere circuit. This is the main circuit breaker. From this, you can get the output. This is sixth one is the DC output. So 7 is the DC input, and 6th one is the DC output. So please note it, both input and output are DC only. So this is the AJ. Now this is AC distribution board. It is like a normal distribution board. So this is also just like a DC distribution board, but here AC supply is being handled. ACDB, it is called ACDB, receives AC power from the solar inverter. From the inverter onwards, AC supply is coming. That should be tackled, manned, it should be controlled, it should be protected through the AC distribution board. After AC distribution board is through distribution on actually. So it is a very important part, you can say, SP system. It is providing extra protection. Okay, so load protection to the load side. Okay, so it is again, it is a monitor system is also there. Some distribution board will have the meter. You can monitor the input power, available power, power consumed, etc. And you can disconnect the inverter from load when you switch off this one. Isolator, of course, isolator will be there. आप इधर भी isolate कर सकता है. Maintenance it will be very easy. आपको अलग-अलग सिस्टम को अलग-अलग करके मेंटेनेंस भी कर सकता है. कुछ रिपेयरिंग मेंटेनेंस करने के लिए it will be easy. Okay. a detailed circuit diagram, you can see this is meter. From inverter supplies coming, phase and neutral supplies are coming here. Through the meter, it is going to the DP MCB. DP means double pole MCB. This is the main MCB circuit breaker. From there, it is going, there's a earth leakage test, EFCB or RCCB or RCD, which prevents the earth leakage. Supplies going, AC supply is going through this one, and phase supply common bus bar link is there. This here AC supply, phase supply is available. This is the SP MCBs, individual MCBs. Through this MCB, individual load के लिए आपका supply जाता है. So this is a different rating you can see, 10 ampere, then 16 ampere, 20 ampere, main MCB 63 ampere. तो आपका ये common bus यहाँ से यहाँ पे phase supply available है. So from here you get the supply to the individual load. So you can control the load. You can switch off load number 8. If there is a problem in the load number 8, you can switch off load number 8 only. Then you can, but it will not hamper the supply to other loads. So after this load. So these are the things. So this is the protection. Okay. So neutral is taken to, this is a neutral link. Neutral from here neutral wires are going, and like this earth link is also there. Earth is also another protection. Okay, so this is the detailed wiring diagram of a AC distribution board. So which distribution board is used from solar string? Solar string आपको together join करने के लिए कौन सा distribution board use करता है? AC distribution board और DC distribution board. DC distribution board को दूसरा नाम है AJB. Okay. Then we see another important part is the cabling, solar cabling, wires. So wires are there, AC cables are there, and the DC cables are there. It is special type of cables are being used in the solar PV system. Okay, it interconnects solar panel. So many connections are there. The first figure we have seen from solar panel to AJB, from AJB to isolator, isolator to battery charge controller to the battery, then charge controller to inverter, again from inverter to AC isolator, AC distribution board, then to the load. So AC cables are required like DC cables are. Both type of cables are required. And we all know the solar panels are exposed to the sun. आपको बाहर रखता है, तो आपका wiring cables are also will be in the outside. So you should have some protection. It should not be destroyed, damaged with the weather condition or the ultraviolet. So it should be resistant to ultraviolet and ozone. And the same way, chemical and oil resistant. Okay, again, it should be a fire resistant property also. That insulation should have all these properties. Okay, and extreme weather condition, your cable should not get, because unlike our house wiring and all, it is not concealed, it is lying outside in the sun. So there are two types of cables, DC cables and AC cables. So nominal feature, normally when we purchase or when we select the type of cable, we should see the specification. आपको specification देखना है whether the it is weather resistant or UV resistant. UV resistant होना चाहिए. Mineral oils और chemicals हमने अभी देखा है. Acid and alkaline battery, we are using the battery. तो बैटरी acid battery हो सकता है या alkaline battery हो सकता है. तो उसमें sulfuric acid होगा acid battery में. तो there's a chances of cable run through the acid. Acid is getting contact with the cable, so it should not get hammered. And voltage rating, how much voltage it can sustain. Is both AC and DC. For example, I'll tell you 1.5 to 1.8 kilovolt rating होती है. You should not break down. Your insulation should not break down. AC it is 1 to 1.2. This is just an example. And high voltage test, how much you can withstand for a small period of time, say 5 minutes. So breakdown test we are using conducting. So 6500 volt देके insulation में कोई problem नहीं होना चाहिए. The normal voltage is 1.5 kilovolt हो सकता है, but the ultimate breakdown voltage is 6.5. This should be tested. Your cable should be tested with this test. and insulation resistance 1000 mega ohm per kilometer. We all know the resistance is increasing with the distance. And the temperature range minus 40 degrees Celsius to plus 90 degrees Celsius. The cable should be able to withstand the temperature range, wider temperature range, because it is close to the temperature change. Generally conforming to the national and international IEC standards are there, some numbers are given. So it should be conforming to the national and international standards. So we should be very careful while selecting the AC and DC cable. And it should be very strong, should be able to withstand the tear, abrasion, etc. Mechanical forces will be applied on the cable as it is open, exposed. So it should be very strong. So let's see the DC cable. It is a single core copper cable, positive and negative separate. So these are the figures of a DC cable. This is a very special type of cable. This is single core, only one core will be there, one positive and separate core cable for the negative. Okay, so it is connecting where DC cable is required, between the modules, string to the AJB, from the AJB to battery charge controller, from battery charge controller to battery. So here we are using the DC cable. So these particular DC cables are used to connect your solar panels together, connecting string to the combiner box, connecting combiner box to the inverter. So here you can see a cross section of this solar cable, DC cable. So this is the conductor, standard conductor. It can be single strand or multi-strand, but core type single core or single core only. So this is one positive wire. So I like this one, negative wire will be there. So here this is the conductor, copper conductor. Insulation color is insulation, and to protect from mechanical problem, this is the outer sheeting, outer sheet. Okay. AC power cable, this is our normal cable connecting inverter to the load through the isolator, distribution box, etc. It can be single phase or three phase. It can be single phase or a three phase. This is a single phase cable. This is a three phase cable, three phase 4-wire system. Red, yellow, blue, and black neutral. Okay. So normally for small voltage system, we are using PVC as the insulation. So insulation plays a major role. It protects, not only protects, it is reducing the leakage current and reducing the draw. So we should be able to judiciously select the type of insulation. For normal low voltage system, we are using polyvinyl chloride, PVC. Whereas high voltage system, where high voltage bigger plant AC cables, we are using cross-linked polyethylene. XLP, this is having more electrical characteristics. Okay, so XLP, cross-linked polyethylene is used. This is a very special type of connector which is called MC4 connector. So MC4 connector, you can see only in the solar power system. Okay, so MC4, it is a single contact connector. Single contact means this one positive wire के लिए एक joint होती है. There is no multi, but it is called MC4 connector. Here MC means multi, manufacturer multi contact. So please don't get confused. This is, of course, it is a solar single contact only. This is the name of the company who manufacturing the MC4 cable. इसका कंपनी का नाम रखा है multi contact. So this is MCS term. The name is the MC implies indicates the multi contact. Now the name is changed also. It is changed to Stobly electrical connectors. Stobly electrical connectors. And 4 indicates the diameter of the contact pin. Depends upon the MC6 is also there. 6 square and diameter wire is also there. So 4 or 6 indicates the diameter of the contact pin. So you can see it is a line, this contact where it is required. If you want to extend the DC cable, So you can use the MC4 connector. This is a very special type of connector. It is exposed to the atmosphere. That is, so it should be UV, ultraviolet resistant type material, say Banava, or water resistant. It is a water resistant. IP68 indicates the grade in respect of the water resistance. Okay, so it is, you can say plug and socket type. Normally in our wall we are using plug and socket method. So same time it is a plug and socket method only. It is two gender, male and female. We can call it as a male pin and a female. Okay, so suppose normally if you want to extend the cable or if you want to connect two solar module in series, we are using this type of cable. If you want to connect in parallel, like multi-branch, so different types of this one of the example, different types of connectors are available. Here you can take 2 DC input together, it can be connected parallel and one output will be there. So for one positive, one for negative one. So like this 2, 3, sometimes it is called as multi-connector, sometimes it is called as Y-connector. So for parallel connection and all, we can use this type of connection. So this is one is female. So this is called the female part of the MC4 connector, and this is called the male part. When you look, you may think this is a male part, but this is a female part because you can see the pin. There will be a pin inside. This is a pin. This pin is going through this hole when you are connecting. So this is a female part. Normally positive is female part, negative will be the male part. So this pin will be inside the connector. So this pin is protected. Pakka protection is there by using the special type of material which is ultraviolet resistant and water resistant. Okay, so you can see this is called fingers. These two are called fingers. The female part will have a finger also. So these are the various parts of a MC4 connector: end cap, strain relief, compression sleeve, coupler body, and the female pin. So this pin will be inside. You can see the difference between female and male pin. So this outer body, you can see the chain. So these pins are inside. So when the cable are coming, the cable can be crimped into this pin. आपका cable इसमें crimp कर सकता है. So it should be inserted in this one. Once it is crimped, this connector you cannot use afterwards. So this is permanent. It is getting permanent fitting inside the coupler body. So wire can be crimped here. This wire will be, this will be going inside, and it will be, when it is tightened, you will get a pakka protection type female and male part. So normally female part is positive, male part is negative. Your female part will have a finger. This is when you are connecting male to female. This allows, this confirms the proper fitting of this one. When you remove, try to remove, you cannot remove directly the male pin from the female pin. Once it is gone, pakka fitted, push fit type. So to remove this, you require a MC4 disconnect tool. Can you see here? You can see you have to insert the MC4 disconnect tool like this, so that the fingers will be pressed. When the finger is pressed, you can pull the pin back. You can disconnect the cable like this. So this is the MC4 disconnecting tool. To disconnect, use so निकालने के लिए करता है. But that once you crimped, when you connect the male or female part to the end of a cable, that is a permanent connection, and you cannot reuse, you cannot remove it from this one. So it gives all the protection to the okay. So there is a question. What is the meaning of 4 in the MC4 connector? आपको MC4 connector में 4 का मतलब क्या है? Okay, so today's class, this is the various parts we have seen. We have not covered the complete part. We have seen the list, what are the components available in the solar PV system. In that, the main system component like charge controller, DC-AC distribution box, cabling and connectors we have discussed today. I hope you understood. Next class we'll see the rest of things like safety system like lightning arrestor, circuit breakers, and mounting solar panel mounting करना है ये सब देखेंगे आपका नेक्स्ट क्लास में.
अरे गीता, तुम मेरे घर आई ये तो बहुत अच्छी बात है. वास्तव में मुझे इंटरनेट के बारे में कई महत्वपूर्ण बातों को समझने में तुम्हारी मदद की जरूरत है.
जरूर चाचा, मैं यहाँ आपकी मदद और मार्गदर्शन के लिए आई हूँ.
देखो गीता,